Beer is one of the oldest and most widely consumed alcoholic beverages in the world. More than 170 million barrels of beer are produced in America alone. Made with all natural ingredients, it is bottled at astonishing speeds. So, how is beer actually made? Beer is primarily made up of 4 ingredients: water, barley, hops, and yeast. Barley is a cereal grain used to brew beer since the 3rd millennium BCE in Egypt, Babylon, and Samaria. Barley is the preferred grain for making beer because it generates a lot of starch-digesting enzymes, forming fermentable sugars that then become alcohol. Barley is one of many grains that brewers use to brew beer. Soft, green hop cones are the flowers of the hop plant, a perennial plant cultivated as far back as the 9th century. The alpha acids in hops are the primary bittering agent in beer. A compound in the cones called lupulin informs the aromatics and flavor notes in the finished brew, such as pine, citrus, or banana. Yeast is a single-cell fungus and a powerful leavening agent that causes bread to rise by digesting the sugars in the flour and releasing carbon dioxide as a byproduct. Brewers may use active dry yeast, lager yeast, ale yeast, and liquid yeast strains to make various beers. The first step in beer production is malting. Malting is the process of soaking, germinating, and drying cereal grains, typically barley, to prepare them for brewing. The malting process activates enzymes within the grains that will later convert starches into fermentable sugars. Here's how it all goes down. Soaking. Fully ripened barley grains are steeped or soaked in cold water until they are fully saturated. The water is changed once a day, and after 45 to 72 hours, the grains are placed in shallow tanks. Germination. The grain is aerated and stirred, which causes it to germinate, releasing enzymes such as malt diastase. Malt diastase converts the starches contained in the grain to sugar for fermentation, drying, or roasting. As soon as the germination is adequately complete, usually 6 days, the grain is roasted to stop the germination process. The exact point at which the roasting starts and ends affects the flavor and color of the beer. The product at this point is referred to as malt. Mashing is the process of mixing the malted barley with hot water to extract fermentable sugars. The result is a sugary liquid called wort, which is a crucial ingredient in the beer-making process. Here's how it's done. Milling. The malted barley is crushed into a coarse powder known as grist. This is a crucial step because it increases the surface area of the malt, making it more accessible to water during mashing. Breweries typically use specialized milling equipment, such as roller mills or hammer mills, to break down the malted barley into grist. These mills consist of a set of rollers or hammers that crush and shear the grains. Mashing. The grist is mixed with hot water in a vessel called a mash tun. This tank is a large copper or stainless steel vessel that mixes the malt with warm water until it is of porridge-like consistency. This mixture is called mash. The temperature of the mash is raised incrementally from 100 to 170 degrees Fahrenheit, 38 to 77 degrees Celsius, which activates the enzymes in the malt, converting the starches into sugars. This process typically involves multiple temperature rests to create a balanced profile of sugars. The liquid contained in the mash is transferred into another tank called a lauter tun. This is accomplished by drawing the liquid out through the bottom layer of mash solids, which acts as a filter. Hot water is added to the top of the mash tank to rinse the remaining liquid, now called wort, from the mash. The solid remains of the grain are dried and sold by the brewery as animal feed. Once the wort is separated from the grains, it travels on to the brew kettles, where it is boiled. Sterilization. Boiling the wort is an important step in the production process because it sterilizes the wort, killing any unwanted microorganisms. Addition of hops. As the wort boils in the brew kettles, hops are added to the mixture. These impart different qualities to the beer depending on which point of the boiling process they're added. Bitterness is one of the fundamental flavors in beer, and it's primarily derived from hops. Hops added early in the boiling process contribute to bitterness. The longer the hops are boiled, the more bitterness they impart. Hops added later in the boiling process, typically in the last 15 to 30 minutes, contribute to the flavor. These hops can add a wide range of flavors, from citrusy and piney to floral and herbal notes. Evaporation. Boiling also concentrates the wort, reducing its volume and adjusting its sugar content. Hot break. Additionally, proteins in the wort coagulate and settle, helping to clarify the beer. The boiling process typically lasts around 60 to 90 minutes. All of this is done inside the brew kettles, which is the most impressive equipment in the process. Gleaming copper, they can be 7 to 12 feet, 2 to 3.6 meters in diameter, and 2 stories high. Steam usually provides the heating energy to the brew kettles. After brewing is complete, the finished wort is filtered again and pumped to the fermentation tanks, but not before it goes through a crucial step. After the wort is boiled, it will be very hot and needs to be cooled before the yeast can be added and the fermentation process can begin. The clarified wort will pass through the heat exchanger to the fermentation tank. Depending on the beer style, the wort cools quickly to 7 to 35 degrees Celsius as it passes through the heat exchanger. The working principle of the heat exchanger is that cold water or glycol passes through the cold water side of the heat exchanger, and the wort enters from the hot water inlet on the other side, and then the cold water or glycol will take away the heat in the wort. Although cold water or glycol cooled the wort, they did not touch it. Fermentation is where the magic happens. In the fermentation vessel, yeast is added to the wort, and it's the yeast's job to convert the sugars in the wort into alcohol and carbon dioxide. There are 2 types of fermentation in beer brewing. Primary fermentation. The initial phase or primary fermentation is when the yeast is most active. It consumes the majority of the sugars and produces alcohol and other byproducts. It typically lasts 1 to 2 weeks, depending on the beer style. Secondary fermentation. Some beers, particularly those that benefit from additional aging or conditioning, undergo a secondary fermentation. This step can take place in the same vessel as the primary fermentation or in a separate one. It allows for further maturation and clarification of the beer. After fermentation, the beer goes through a conditioning and maturation phase. This step can vary in duration, from a few weeks to several months, depending on the beer type. Flavor development. During conditioning, flavors meld and mature, producing a smoother and more balanced beer. Clarification. Conditioning also clarifies the beer as yeast and other solids settle to the bottom of the vessel. Carbonation. If needed, additional priming sugar may be added to achieve the desired level of carbonation. After conditioning and maturation, the beer can be pasteurized to kill the remaining yeast and prevent further alcohol production. This is accomplished by heating the beer above 135 degrees Fahrenheit, 57 degrees Celsius. This process, named after Louis Pasteur, is widely known for preserving milk. Interestingly, Pasteur originally developed this process to preserve beer in the 1860s. Pasteurization, however, is not used in the production of genuine draft beers. These beers are also known as ice beers, since they must be kept refrigerated to preserve their flavor and slow the remaining yeast activity. Many consider the draft beers best in aroma as well as taste. Once the beer has pasteurized and is ready for consumption, it is packaged in various formats, including bottles, cans, kegs, or even casks. The packaging process is crucial to preserving the quality of the beer. Filtration or centrifugation. Some beers are filtered or centrifuged to remove any remaining solids and yeast before packaging. Carbonation. If the beer requires additional carbonation, it can be achieved by adding priming sugar before moving forward with packaging. Bottling or kegging. After the beer has been filtered and carbonated, it is transferred into bottles, cans, or kegs and sealed with caps, lids, or corks. Labeling and branding. Finally, labels and branding materials are applied to the containers. Quality control is a vital aspect of beer production. Breweries employ various techniques to ensure that their beer is consistent and free from defects. Taste testing. Regular sensory evaluation is carried out by trained testers to assess flavor, aroma, and overall quality. Chemical analysis. They also measure factors like alcohol content, bitterness, pH, and color to ensure consistency. Microbiological testing. Most breweries have a team that carries out microbiological testing on site to make sure that the alcohol is free from unwanted microbial contamination. Packaging inspection. Moreover, workers check for defects in packaging materials to maintain product integrity.